Thank you all for being here today. I'm super excited to be moderating today's event titled Breaking Into Additive Manufacturing, the 5 Steps to Successfully Adopting 3D Printing. And this is actually the second of a 3-part webinar series where we're diving into all things 3D printing. And so if by chance you missed the first session in this series where we worked to separate the hype from the reality of 3D printing, you don't want to miss some of the unexpected insights that we were able to draw out of that session's panel. So if you want access to the private recording, do this right now. Drop your best email in the chat, whether that's on LinkedIn or in Zoom. Drop your best email, and my team will follow up with you after today's session so you can get access. So who would like that? Go ahead and drop that in the chat right now here in Zoom or in LinkedIn, and I will make sure that my team follows up with you in order to get you that recording. I think that we just got Dennis in. Okay, perfect. Looks like Dennis is here with us now. Perfect timing, Dennis. Welcome. Thank you for being here today. I'm joined by Kevin Carr, Vince Annawinter, and Dennis Richards to discuss how to get started and accelerate your additive manufacturing journey by looking at 5 key steps. And our goal in the next 60 minutes is to dig into these 5 key steps. And my job is to pull out of this panel, who I'm going to introduce you to here in just a second, insights that are meaningful to all of you, no matter where you stand in your journey. Briefly, allow me to introduce myself. I'm Dave Rosendahl, president here at Mindfire. My company's had a long relationship with manufacturers, specifically the print industry, in both 2D and 3D print. And through that experience, somehow I've become a connector, bringing folks together to learn from panels like the one that we have prepared for you today. And my job is to moderate the discussion. That means not only am I moderating the live panel that's here with you today, but also all of you who are here in the room. So please, right now, go to Zoom, open up the chat, and say hello. If you just came in, drop a hello there in the chat, or in LinkedIn, say hello, because what we have found is that the more engaged you are, the more you get out of these sessions today. So I want to make sure I see the hellos coming in. I see Ray saying hello, Craig says hello, Dean says hello. Please go drop a hello in there. And if you're ready to get started, please drop a yes. Please drop a yes on LinkedIn and in Zoom. Let me know if you're ready to get started, because now I'm going to introduce the panel to you. And I'm going to go through one by one, give you a little background on each, and give them an opportunity to say hi to all of you who are here in the room. So first up is Kevin. He is the president at MasterGraphics, where for over 70 years, they've sold wide format and graphics printers. But more recently, they've expanded to offer 3D printers from HP, 3D Systems, 3D Platform, Ultimaker. And today, they're focused on partnering with manufacturers to successfully implement additive manufacturing. And their goal is to help the industry, all of you who are here, successfully adopt 3D. And Kevin's really been leading the industry and helping the 3D print community learn and get inspired and take action through events like the one today. So today's event was Kevin's idea, and we're grateful to you, Kevin, for pulling us all together. How are you this morning, my man?
I'm doing great. Thanks for hosting, as always, because you do a great job. I love the excitement and appreciate being here. And I'd be remiss, I want to thank the panelists. Of course, you talk very highly of me, but I appreciate Vince and Dennis joining us because they really are the experts in the industry. And as I love for these things to be informative. And Vince and Dennis, I love talking about other technologies besides what we just sell, because I really want it to be education and continue to push the AM market forward. So again, thanks for hosting, and thanks for the panelists for taking the time out of their day to join us.
Absolutely. I'm going to introduce them next. I'm going to ask my team, though, to drop your LinkedIn profile into the chats, Kevin, so that folks, you can connect with Kevin on LinkedIn and get that connection open with him if you haven't yet met him. Let me introduce now Vince Annawinter. You can see his picture here on the screen. I'm going to bring him up in a second. He's the director of the Rapid Prototyping Consortium at the Milwaukee School of Engineering. And there he gives additive manufacturing guidance and new product development expertise to a non-competitive consortium of over 47 companies located across the globe. And he brings to that role deep experience in additive manufacturing, 3D scanning, injection molding, stamping, castings, and product design. In addition to that, he also serves as the treasurer and director on the board of the Additive Manufacturing Users Group, AMUG, as well as serving on the boards of the St. Louis University Center for Additive Manufacturing, Azul 3D, and the Photopolymer Additive Manufacturing Alliance, or PAMA. Vince, a lot of words that are difficult for me to say there, but thank you for being here with us today, and I appreciate you spending time with us and the panel.
Hey, it's a real pleasure. Looking forward to participating. I appreciate everybody tuning in. Obviously, I love additive manufacturing and love the opportunity to talk about it, and this is a great group, so thank you very much.
Awesome, thank you. And team, if you can drop Vince's LinkedIn information there in the chats, I want to give everyone an opportunity to connect with you too, Vince, there on LinkedIn. And also with us here on the panel is Dennis Richards. Dennis attended the University of Missouri in 2002, and then Northwestern University Medical School's Prosthetics Orthotics Center, and graduated there in 2004. He's an ABC certified orthotist, and he founded 3D Stability in 2009. And around 2014, he began his digital transformation, and 3D Stability now runs a fully operational O&P 3D printing lab using in-house MJF and MAT vapor smoothing technology. Dennis, we appreciate you being here as well with us this morning. How are you today? Dennis, we got you here? I think, Dennis, you're muted. If you could unmute, just say hello.
Oh, sorry.
There you go.
Thanks, David. Thanks. I'm so happy to be here. Excited to talk about 3D printing and share some of my successful stories with everyone.
Awesome. Dennis, we're going to give folks an opportunity to connect with you on LinkedIn as well. Team, if you can drop that into the chat. You're going to hear from these folks now, but before that, I don't want to forget. I want to remind all of you that if you're here with us until the end today, I'm going to check the log. I'm going to have my team check the log. You're going to receive this new white paper that outlines the roadmap to success with 3D printing. So please make sure you stick around to the end of the panel today. And like I said, I've asked my team to check the roster of who's here, and we'll make sure that you get this roadmap as soon as it's published early next week, the moment it hits the airwaves. So make sure you're here to the end to get that guide. All right, let's jump right in. Let me tell you how we prepared the material today. I have in front of me hundreds of questions. There you go. You can see it there. Hundreds of questions that you've all submitted in advance of the event today. And it was my job, along with my team, to pull out the questions that you've asked that are most illuminating in the 5 steps that we're talking about today around adopting 3D printing. So that's what we're going to be focused on today. But Kevin, I'm going to bring you into the hot seat first. Before we do that, for those that didn't join the first in this 3-part series, just give us a little background on yourself. Tell us about what drew you into 3D, what challenges you had to overcome to get started, and how you got to where you are today with MasterGraphics.
Yeah, it's interesting because we started as a traditional 2D wide format printing company. And when I joined MasterGraphics probably 14 years ago, it was a small part of our business selling 3D print. And it's interesting, in the 2D side, we sold printers because people needed them. But I saw 3D print as a way that was changing people's companies and really adding value and changing the way they worked. So it excited me on a personal level. And then over time, as the industry focused and we went from prototyping to production, we had the ability to partner with someone like HP. And it really it generated that growth in our business to focus on additive. And so where I get excited on a daily basis is what we're doing to change manufacturing in the US. And so that's been a focus of ours. We still do 2D print. I can't forget about that. One in the company tells me, but it's just been an exciting progression. And then just get in this small industry still with people like Vince and Dennis and really do things differently than we've done in the past. So it's just been a great evolution. And like I said, it's exciting every day to get up and work in the industry. So it keeps me driven because it's so enjoyable.
Vince, what about you? How did your 3D journey start?
Yeah, no, great question. So I started off my career in traditional manufacturing, plastic injection molding, tool and die, and gosh, probably late 90s. I remember reading an article about 3D printing and how it was going to affect injection molding and plastics. And I thought, wow, this is the future. And early 2000s, I had an opportunity to come work at Milwaukee School of Engineering in their Rapid Prototyping Center. And they had a great center already started. We've been around since 1991, helping companies understand new developments in this industry and how to integrate it into their operations. And I just fell in love. I fell in love with with helping companies adopt new technologies, with the ingenuity and creativity necessary to really adopt and deploy a tool that hasn't existed yet. And so this industry is so much fun. There's so much opportunities to make a huge difference in the world. And that's, I think, what really drew me in. So it's been a fun ride ever since.
Dennis, when I was researching you for today's event, I noticed that your journey with 3D actually started through 3D scanning. So I'd love for you just to tell us a little bit more about why you were drawn to 3D and why you started through scanning.
Sure, David. So when I was in school, I actually saw a 3D printed prosthetic socket. And that really was amazing to me. I was just totally fascinated. But as 3D scanners became more available, I bought one and just started playing around with it. And I would scan objects, and then I would actually scan those objects and then send them to a 3D printing service bureau to have those printed. And once I started to do that and became accustomed to doing that and saw the amazing these devices that I was able to 3D print, that really just sucked me in. And I guess from there is history. So that's where I am today.
Got it. I asked those questions of you folks because I want everyone here in the room to have context for where you're coming from as we dive into these 5 key steps. And in the last webinar, again, if you missed that, drop your best email in the chat and we'll get that panel discussion over to you. But in the last webinar, Kevin, who was here, asked if we're new to additive, where do we start to ensure that we're setting up properly to maximize our efforts and our investment? And that's exactly what I want to dive into now. So the first step to understanding how to identify profitable opportunities within additive manufacturing is where most organizations start. For many, they want to understand the investment opportunity, why now, and how do we best assess the ROI of this technology. So let me start with a question that's probably on many minds right now, which is related to the state of the economy. And as we think about the state of the economy and making this investment or accelerating our investment in 3D, I'm going to start with you, Kevin. I want to know, why do you think that now is a smart time to invest in additive and do so in the face of what's possibly a looming recession? Kevin, what are your thoughts on that?
Yeah, I think, look, in our world, the supply chain has changed forever, right? So some of this, when we talk, it seems like buzzwords, but it's a reality, right? It's why they become buzzwords. So additive really makes us more adaptable and we can address more issues. So I think for us, we've had this reshoring talk for many years, but we really are at a unique inflection point because all of our customers in the US have been affected by that supply chain, and additive can address it in a different way. So if I look at customers of ours like Enerpac and Graco, they've really set them up for the future and they're able to adapt and address theirs. So when you talk about investment, always comes when you find a pain in your company that you can address. So I use Michael at Enerpac as an example. He sits on their supply chain committee, and we had one specific one where they were waiting 8 weeks for a part before they can do a final assembly, and he's able to print that part and get the line back up and running. So I think even with kind of that, all our concerns about the economy and that, additive really does allow you to address those concerns, so you're not relying on other supply chain. You can be more adaptable. And like I said, you can be better set going forward to address any issues that might come up. So like I said, I think so much has changed and it sounds like buzzwords, but additive really has addressed a lot of the challenges you've seen and that we're going to see in the future.
Vince, what about you in the face of 2 negative GDP quarters here? So technically a recession, and who knows what else is coming our way. Why do you think now is a good time to invest?
That's a great question. And Kevin, you brought up so many good points there. A lot of companies are struggling with changes in the supply chain. And like I said, when I started my career in manufacturing, we were at the cusp of the first outsourcing wave. And really, a couple of things happened there. One, we lost a lot of infrastructure in this country for manufacturing, and we lost a lot of talent. And there's a void of talent. And I think smart companies are always looking to be innovative. Smart companies are always looking to build on what's next and develop a competitive advantage. And to echo a little bit what Kevin said, one of the big opportunities that additive provides is it's a very nimble tool, right? It's not to say that additive is immune to supply chain challenges. We have those same challenges in our industry, getting materials or what have you. But because it's nimble, it allows you to be flexible and dynamic. It allows you to address limitations for other sources for parts. And it also allows you to address the talent shortage and the talent gaps. We're seeing more and more applications being developed in additive on the jigs, fixtures, assembly, tooling, things in those areas that help you maximize the workforce you have and that kind of alleviate those skill gap challenges in your technical manufacturing workforce. So lots of tools, lots of ways it can create benefits in your internal operations.
Vince, in advance of the session, Tyler submitted a question around can and how, if so, does additive manufacturing provide a competitive advantage, a distinct competitive advantage? So Vince, can you just, from your perspective, how would you answer that back to Tyler?
Oh, that's a great question, Tyler. There's lots of ways it can provide a competitive advantage. I think when you look at adopting additive as a company, I think it's really important to look at what your biggest pain points and your challenges are. If you're out there looking at doing a nickel price reduction on a piece part pricing, that's probably not a good fit. But if you look around your factory floor, your operations, and you say, what's my biggest headache? And you look at how additive, which is a tool in the toolbox, it's not a cure-all, but it's a tool in the toolbox, how it can play a role in solving your challenges, whether it be for rapid dynamic prototyping, a flexible end of arm tooling. I think that we're seeing a big movement toward scalable, low volume automation to help alleviate some of these challenges. And additive plays a huge role in flexible, quick change, down and dirty, low volume automation tools, whether it be fixtures, end of arm tooling, vacuum chucks, you name it. There's a lot of ways you can deploy additive to improve your productivity and your quality in your operations, including rework. We've done a lot of projects where maybe parts are coming in or parts need to be modified and you need a quick way to fixture those, hold those, assemble those. And those are all great applications for additive. And having that in-house really is a game changer, because you try to get anything outsourced these days and you're looking at shifting timelines and oftentimes 6-8 weeks. It's a challenge. So the ability to be dynamic in-house and control your own destiny is huge.
Dennis, I'm curious from your view, orthotics, how do you answer a question like Tyler's around how does additive provide a competitive advantage? What are your thoughts on that?
David, just being able to create these advanced 3D graphics and advanced geometries with additive, it really, there's nothing that really compares to it with traditional manufacturing. If you could pull up the photo, I think you have one there of a. Yes. So if you look at the graphics, they're pretty amazing. Just something this little girl wanted on her little AFO. But if you look at the side view image of that, you can see there's a channel that runs through there, and it's a perfect spot where I can run a strap, which not only is it, the graphics are amazing, but it's also functional. And that's, I think, something that we're just now learning with the software available to be able to create these type of devices that have the 3D graphics that the children want, or the adult or whoever, but to also make it fully functional. And so this is something that can't be done any other way, actually.
That's wonderful. This definitely resonates with me, having small girls, and I can imagine that even just for the recipient of that, this is something that makes that process a little bit easier to take in. So thank you for sharing that example. Let me ask you, Dennis, going back to you, this next question here, what would you say to someone who says to figure out the best way to determine the cost benefits for additive manufacturing over traditional manufacturing? Craig and many others asked that question around how would you guide someone in assessing the benefits of AM over traditional manufacturing? How would you answer that, Dennis?
Yeah, this is a question I'm asked on a regular basis, and it's difficult to really compare the two because you're going from a 3D printed additive manufacturing from a traditional handmade. So there's a big jump between the two, but I think if you're looking at if you're comparing the cost, it really becomes, you're going to save on the labor side. Like you were saying earlier with the labor shortages, the increased cost of labor. So I look at my 3D printer as a form of automation, because traditional, you may be able to hand make one at a time, where with a 3D printer, I'm making several devices at one time, and it's done unattended. So it's done usually at night. So that's the best way for me to describe where you're going to really get the cost savings. But outside of that, there's other value to 3D printing besides just the cost too.
So Vince, I'm going to throw this one at you. I'm just curious then, coming from outside the industry and looking in, what would you say is the number one reason that you feel most companies do not invest in 3D printing? I saw Allison and many others wondering the same thing. What is it that's keeping companies from investing? How would you answer that, Vince?
Yeah, I would. That's a great question. And I would say, unfortunately, there's probably two things that keep companies from investing in 3D printing. And one might be a problem with the early legacy of our industry, and maybe it was that they had a bad experience initially. We see a lot of folks that maybe got in early, and they had maybe unrealistic expectations. And really, let me just put a plug in for Kevin on this. One of the things I really enjoy about working with MasterGraphics and Kevin is that they are a very pragmatic, realistic partner, and they do a great job of helping potential customers understand what realistic expectations are for the technology, where it will work and where it won't work. And I think that early on in our industry, we had a lot of opportunities where folks did not give accurate expectations, and folks got scared away. They had a bad experience, didn't work out well, didn't meet expectations, and then they went away. So I think that's a big one. I think just fear of the unknown is always big. I really commend folks like Dennis. It's been hard to adopt additive in a lot of traditional industries because a lot of folks get threatened by new technologies, and getting over that fear and adopting new challenges is really a great opportunity.
I'm curious for all of you in the audience right now. So Zoom and LinkedIn, do you resonate with that? The idea that perhaps from one perspective, what we're battling is a little bit of the hype versus the reality, which is what we talked about in the first of these series, the first of the webinars. Does that resonate with anybody here in Zoom? I want you to go over to chat. Let me know if that resonates with you. If you're on LinkedIn, throw that in the chat if what Vince just said resonates there with you. Dennis, I'm going to throw the same question to you. What do you think has kept organizations from investing in 3D from your perspective? Dennis, you may be muted. Yeah, Dennis, go ahead and unmute.
So in the field, everybody's concerned about failure, whether these parts are going to be strong enough. And I think that's overall the number one concern. But I can tell you that since multi-jet fusion was available, I've been 3D printing since 2018. And early on, there were some issues more on the CAD side of things for me, so I could really figure out exactly the thicknesses, the materials to use. So there was a lot of trial and error during that year. But ever since we got through the trial phase, it's been nothing but good. Every once in a while I have an issue, but for the most part, I've got hundreds of cases now that these patients are doing very well in their devices, and it's gone very well for me.
Yeah, interesting. I see from Mark, thank you for this comment here, adding some additional perspective that some of the low-end personal printers don't meet the professional expectations, and so perhaps folks have been misguided by that or given the wrong impression. What I want to do, folks, is ask you this same question. I'm going to ask you a variation of the question that I just asked Vince and Dennis. I'm going to do that through a poll here, so if you can turn your attention to the screen, go ahead and look at the screen here. What I want to know is what's holding you back. So if you haven't yet adopted or if you have but haven't yet fully embraced 3D printing, what would you say is the #1 reason holding you back? Let's do a little intel gathering here, and then I'm going to share back the poll to all of you so you can learn from your peers as well. So if you haven't started, what's holding you back? What's the #1 reason? Or if you have, but you feel you haven't yet fully embraced the technology and the potential, what's holding you back? No clear ROI, lack of qualified resources, the learning curve. Maybe you don't think 3D can handle your use case or something else. Put that in the chat. I'm gonna give you a few more seconds. Come on, want everybody to get out there and give an answer here. We got 41% of you in Zoom having answered. LinkedIn, go ahead and just throw your throw your response there in the chat for us. I see Patrick over there. All right. If you're picking something else, make sure to put that in the chat. I'm going to give you another few seconds here. All right, let's take a look at how you and your peers answered this question here. I'm going to pull it up and share the results with all of you. So here we go. Interesting. We have 33% saying that there's no clear ROI, followed by something else. So please go put that in the chat. I want to know what those something else's are. And then we've got at 16% both the learning curve and 3D can't handle my use case. And lastly, a lack of qualified resources. Interesting. Kevin, I'm just curious from your perspective, how does that line up with what you thought we might learn from this room?
It's interesting. I was going to, and I would be curious if Vince and Dennis say this, but ROI is always the challenge. And it's what we see a lot is it's that first acquisition of a 3D print or an additive solution. Then the second one gets easier because then they understand it better. But no question, ROI, Dennis talked a little bit about trying to compare the two. And Vince even talked about, which was a great point, if you're trying to make it cheaper for the material, it's probably not going to work. So I think ROI is one we always run into. But on the positive side, those who have implemented it, their second, third generation or additive, that's when it gets easier because they have a better internal understanding of what the ROI is. And sometimes it's soft. It's not a clear-cut cost. And so I think that it's funny, as I was seeing that, it resonated. It's by far probably the biggest challenge we see.
I see comments coming in here to Zoom, and I want to make sure we get to all 5 steps here. So please keep those comments in. If you have any questions, if you see something differently, please drop it into the chat. And then when we get into the interactive Q&A portion, I'm going to be reading more of those out. So let's talk about step 2 now, which is where we want to assess the challenges that get in the way and how to navigate around them, creating a plan to navigate around those. So I'm going to go to you first, Vince, and ask you just to summarize for us, what are the common challenges you think companies face when they first start with additive?
Yeah, that's another great question. A common question that comes up. I think there's a couple big items. One is expectations, realistic expectations. And a lot of people come into additive with a very binary mindset. Either it's going to work for everything or it's useless. And I think that it's important to understand it's a tool in the toolbox, and you don't have one tool that you use for everything. So you have to have much more of a holistic viewpoint when you're adopting additive. And to echo a little bit about what Kevin just weighed in on ROI, sometimes our current evaluation metrics don't really lend well to a new tool that doesn't exist because we don't have metrics that exist either. Why would we for a tool that hadn't existed? And we want to do these traditional ROI kind of tools and justification tools. And so it's easy to look at piece part pricing. It's a little more difficult to look at risk mitigation or reduction in inventory or the nimble nature of having a flexible manufacturing tool on your premises, having something that can alleviate labor problems. Those sorts of things are often areas you have to look at. So I think how to assess challenges, I think, and be successful, it starts with realistic expectations, and then you have to have a much more holistic viewpoint of your enterprise, of your organization, and look at where the root cause of all these sources are and start understanding how this can play a role in alleviating those pain points.
Dennis, I'm really curious about your situation. If you can think back to when you started your endeavor, what were the challenges that you faced, and how did you overcome those? How did you work through them when you started the organization?
So the big challenge was getting started and not understanding CAD. There was just limited courses I could take, and I think for the most part, the practitioners in the field are all very limited on time. They don't have the time to learn CAD, to relearn how to design. Basically, you have to jump in and you have to do it. You can't expect your first try to be perfect. You got to go in with, Vince was saying, the expectations that, hey, there's a learning curve, but that's you just got to assess your situation and where you want to be, and just get a better understanding of the technology. And I think that's if I could say anything, that once you start doing it, once you learn it, you'll take off from there and you'll never turn back.
So you mentioned CAD, which is interesting. There was a question that came in from Alexander, actually, saying or asking, does additive manufacturing and 3D printing, is there a steep learning curve for someone who's looking to start? So I'll go back to you, Vince, first on this. What do you think about the learning curve for those who are just getting started?
Yeah, there's absolutely a learning curve. I think understanding the limitations of the technology and the opportunities. There's a lot of talk about the materials and diminished mechanical properties and things like that, but the truth is, in our everyday life, actually a colleague of mine, Gideon Levy, put it best one time. We were chatting about this over breakfast, and he said, look, the world's most common material is lumber, and it has the most dissimilar mechanical properties there is, but we found a way to make it work. And I think having a good understanding of what additive is, and then being able to design around it, I think is critical. And I think additive is becoming, the ecosystem is growing, right? We've reached a critical mass in our industry. So I would say CAD was a challenge early on, but there's some great innovative tools coming out to help us really unlock the value of additive. Again, we created a new tool. Now we have to create additional tools to help us leverage that tool. And that's coming, whether it be automated post-processing, finishing. There's a lot more tools coming on board, which are helping us enable unlocking the value for additive.
Dennis, would you say from your perspective then that scanning is the key to overcoming that learning curve?
Oh, yes, absolutely. You got to get a scanner. You know, they're relatively inexpensive, and they're for our field, being able to scan body parts, very accurate. So absolutely, that is the first step. And then because there are other sources, there's other design companies, there's other ways to learn CAD, but you got to start scanning, especially in our field. It starts with scan to CAD to design to print. So that's the first step. Absolutely.
Got it. Got it. Makes sense. I see lots of great questions and commentary coming in. My team, please keep some of those good questions. Yes, the question, Allegra, I meant was from Ed. I want to get to Ed's question here during Q&A. And MasterGraphics team, feel free to chat with folks there as well so we can keep the engagement good and high there in the chat. Thank you all for keeping that chat lively. Let's talk about step 3 now, where we want to dive into how an organization now identifies the best use cases, the best applications that prove out the value of additive manufacturing. So now we're in step 3 of this process. And Kevin, I'm going to go to you first here. A question that came in from Vidal, hopefully I'm pronouncing that correctly, which is around what is a cost-effective way for small companies to acquire the skills and the equipment for additive and 3D? Kevin, your thoughts on that?
It's interesting because I look at them in 2 different ways, right? You take equipment and skills. And from an equipment perspective, obviously a lot of the pricing points have come down, right? Again, I would caution, you want to make sure you buy the right equipment for the need. But there are new ways, now that we're getting more mature, as Vince was saying, to get a device as a service. So you can pay as you go. There's more rental, there's more leasing. The equipment options have become much more flexible, I would say. And that's really one. And that's the one everyone focuses on. I actually think one of the bigger challenges when you talk about effective is that skill set, right? I think the biggest challenge we have in adoption is look at the skill that Dennis and Vince have gotten over their career. But I think you have options. I look at students coming out of MSOE, and I know Vince was so nice to me earlier, so I'll be nice back. But if we look at some of the best service bureaus in the Midwest that we have, they were MSOE grads, right? So you have the ability to use resources. Our educators are getting extremely better at it. Our technical schools are getting better at teaching that. I think even more resources. From a skill perspective, I think both Vince and Dennis would agree, you have to get all in, and there's all sorts of resources. There's education, there's now consulting groups around additive. I have this concept of this additive manufacturing cell where you bring in parts, people who assess parts, talk about facilities. And so there, you have a lot more resources, but skills is probably the biggest challenge. But like I said, look to your local educators, look to your local companies. I think you can leverage them for sure to understand it.
Greg, I see your question here in Zoom. Definitely, let's hold that one. Allegra and team, let's get to that one. I want to ask you, Dennis, the same question. From your perspective, what do you think is a cost-effective way for smaller organizations to get the skills and the equipment that's required for additive? How would you go about solving for that?
I think the first step is to come up with a design or reach out to design companies. They're popping up now, and then have it 3D printed. Send them to a service bureau or somebody like, get in touch with somebody like me that's in the field, that understands the design and the patient population. And to find that perfect, we got to be very selective. There's a learning curve, but you got to print them, send them to a service bureau. And once you feel comfortable with that, that's when you take the next step, maybe to look at investing. So start with having somebody print for you.
Vince, Jeff from KSU asked, and we've touched on this a little bit today, but he's wondering, how do you affordably and profitably stay current with the technology in the face of an industry that's rapidly developing and evolving? How do you do that, Vince?
Yeah, that's a that's a great question. That's a never-ending challenge, especially in a university environment. MSOE is a great small private university, so definitely very capital cost conscious. So we've had to get creative. So we're financially supported by our non-compete consortium of companies, and helping companies adopt additive is at the essence of what we do. And so it's very important for us to stay at the forefront of emerging technologies, right? There's less value in adopting aged technologies. There's more value in adopting the latest and greatest. We have taken that opportunity to develop ourselves as one of the elite beta testing sites in the US or in the world, really. We get involved in a lot of beta programs. So we help the OEMs, the companies developing the new printers, understand where their technologies can fit, any challenges they have pre-market, pre-launch, identify potential case studies or applications. Every company wants to come to the market with a couple successful applications. And then reciprocally, what we offer to our consortium members is early access to new technologies to help them understand these and how they can make a compelling difference in their operations. So we've had to get a little bit creative when it comes to the constant challenge of buying new capital equipment.
Yep.
I will say that there's a lot of good technologies that are coming down in price, and it's becoming less and less of a barrier to adoption.
Dennis, if I could get you to unmute, I'd be curious on your perspective here. How do you stay on top of rapidly developing and evolving technology? How do you keep your finger on that pulse and stay ahead of it?
It's you just have, I mean, it's just part of your daily, you read articles, you're doing research, because I'm constantly looking for better. So whatever I can get my hands on, so it just becomes part of your business and what you're doing on a day-to-day. As far as to invest in whatever technology, multi-jet fusion made sense for me at the time. And looking back on it, I know it was a little scary at first, but I feel like I made the best choice I could ever made. And it was definitely scary, but I feel like I'm in a good place at the moment.
I've seen a lot of questions come in here. I'm going to go to you, Kevin, but Dennis first on this one, around the idea that additive might be, or 3D printing might be best as a one-off type of manufacturing versus mass production. And Ryan had asked a question similar to this, wondering, is the process primarily viable only in the one-off scenario, or is mass production in the cards? Dennis, how do you respond to that?
That's, I think in our field, that's the investors, people are looking for more of a mass production. They're just looking for that. And I think currently, I think we're set up really well with 3D printing for these one-off products, but there's AI and the development of this new software. And I think they'll be able to rapidly design and produce. And I think that's our future for sure. I see it coming. I'm watching it very closely. So I think the interest is there. And I think the investors are really taking note of that and watching that technology emerge as well.
Kevin, obviously you've invested heavily in this space. I'm curious your view on this.
Yeah, it's interesting. And I think you have one of the graphics on it. So it's funny, we're going to talk a little out of both sides of our mouth on the overall cost, but we still see the one-off high value items. But what we've seen is this pretty dramatic push down of price per part and the ability to print a larger quantity. So this is just an example. We went to a local shop to try to get a mold made, and we just compared it to additive. And our turnaround time is actually quicker. We're not waiting 8 to 10 weeks for a mold, and we're able to produce it. And the volumes have definitely increased. I kind of look at it, think of EV models, right? Like Rivian and all these guys who've started. They could not have done this, I don't believe, 10 or 15 years ago. Why did no one compete in the automotive market? You couldn't develop a product, but additive has helped it. And they can now go, and some of those parts are actually being produced and put in a car. So I know this is talking a little bit about the little opposite of what Vince and I talked about, but there is some validity in turnaround times, not having to make a mold, and that crossover point of traditional manufacturing and versus additive, that point is going up. So we are seeing this, right? And like I said, you see it in EV vehicles, Ford and GM now speccing out MJF, SLS parts in their actual end use vehicles. Again, this is another just direct a maturity of the market. Our costs are being driven down.
Got it. All right, let's move into step 4 here and dig into how you learn to design for additive in a way that fully capitalizes on the capabilities that it brings. Vince, I'm going to hit you with this one first from William, who said, how does one change the design mindset from traditional manufacturing to 3D printing? Vince, how would you guide William and the others who have that question and how they change their mindset?
Yeah, that's a great question too. So often it's a pet peeve of mine. I hear folks that say, oh, what we need for great additive designers is people who don't know anything, right? People who aren't pigeonholed into a certain skill set. And that bothers me, because really what I think makes the best designers are folks that have understood how to design for lots of different manufacturing processes. And additive is a manufacturing process, right? And you wouldn't design a part the same way for blow molding as you would injection molding or thermoset molding. It's totally different. And truth be told, there's a lot of different design metrics that you need to put in place for the different additive processes. And so I think to start with, you need to understand the process you're designing for, what the opportunities and limitations are for that process, because every manufacturing process has those, and then maximize your design. I always say, especially when teaching students, I don't want additive to be an excuse to be a lazy designer. Additive manufacturing is probably one of the most expensive manufacturing processes on the planet. I don't think I'm shocking anybody with that when you look at the cost of material or the piece part pricing, and that's why you have to bring in all these external forces to or inputs to cost justify it. That being said, it requires you to extract value out of every component of your design. And with these some of these wonderful new software programs like N-Topology, Altair, OptiStruct, mass optimization technologies, there's designs and there's tools that are coming up with optimized designs that can only be produced with additive. And it's going to produce game-changing opportunities in a wide variety of different industries. And a lot of it's coming down to the development of ancillary technologies, scanning, mask optimization, digital foams, those sorts of things. So don't design the same way you did for injection molding. If you think you're going to have a successful design with an injection molded design for additive, you're probably not, right? You've got to look at the process.
Kevin, curious as to how you see this. How does an organization or a person change their mindset when going from traditional to 3D printed? How do you guide somebody in that process?
Oh, it's funny. It's probably why I just, again, appreciate where Vince is coming from, and is it's just another tool in the toolbox. You got to start with that. And I think one of the challenges we have is going back to Vince was talking earlier about the overhype. And too often we go in and we want to tell them, you got to design for this because it's better. And it really isn't. It's what is your end use product? So you need organizational buy-in, right? That understands it. And honestly, the other piece you need is understanding of different technologies. We're selfishly, we sell HP and 3D systems, but sometimes carbon is a better solution. So I think the organization's got to buy in, educate their designers on the different technologies, and then they'll understand how to use it. And the other one I would say is the understanding new tools. CAD tools, even though relatively easy, some of the new ones you design differently, you think differently through it, and you need to invest in that type of new tools so that you can leverage whatever technology is out there, 5-axis now, whatever it might be. And so I think you just got to continue to do that, but it is just another tool in your toolbox, and you got to educate it, and you got to understand the manufacturing process, because it augments it. Really, it doesn't displace it in most cases.
Craig, I see you've got a question here around what's viable for additive. Team, let's make sure we grab that one. Mark, I see you have an interesting insight. Changing the mindset is similar to moving from the drawing board to CAD. That's interesting. Vince, let me ask you this question. What challenges do you face with post-processing?
That's, same challenges everybody else does: manual labor, time. Post-processing can often be one of the most expensive components of the process in producing additive parts. And like I said, we're getting to a critical mass where some of the tools that exist in other industries are starting to play a role in allowing additive to scale. There's vision systems and parts sorters, automated processes that I've seen. You think of as we start to produce large volumes of 3D printed parts and they come out in a big cube, if you will, sorting those out into the right orders is a challenge. It's time consuming, challenging from a quality standpoint, not missing parts, not putting different orders in with the wrong ones, especially as you look at, say, mass customization or serial production. It can be a challenge. So tools such as adopting vision systems, automated post-processing, automated finishing, that's all leading the way in allowing us to really go after some higher volume production applications.
Dennis, in your business, with your parts, what challenges do you face with post-processing?
So early on, multi-jet fusion, I was early adopter. The challenges are you've got to have exceptional post-processing. The parts have to be completely smooth. They just have to be completely finished because we're applying those to a patient. Just recently, until I discovered the AMT vapor smoother, I was doing some processing by hand, which was very time consuming, but like they're saying, hey, these things are becoming more automated. There's better machinery. AMT I just purchased a machine from them, invested in this technology because it's an absolutely essential part of what I do. Absolutely.
Got it. All right, I'm keeping an eye on the time here. Let's talk about step 5 here, and then we're going to get into all the real-time Q&A. I want to talk about the in-house versus service bureau question. So how do you know when to do something in-house versus sending work to a service bureau? So what I want to do first, before I pose this to the panels, I want to get a sense for where you're all at with this. I'm going to launch another poll here. if you turn your attention to the screen, I want to get everybody to answer this. I'm going to give you a few seconds. How do you currently employ additive manufacturing? In-house? Do you use a service bureau? Some of you do both in-house and service bureau. And then, of course, there are some that don't do any 3D printing. So take a moment, turn your attention to the screen. We've got over half of you having voted already. Come on. Get over to your keyboard. A few more seconds here. Let's get a few more. Come on, one or two more. There we go. I see the numbers climbing. All right, I'll give you one more second. How do you currently employ additive manufacturing? And the results are, oh, I still see you voting. All right, here are the results. Let me bring those up on the screen here for you. I'm going to share the results here. And we have, let's see here. Number one, 36% of you in-house, followed by, interestingly, 33% don't do any 3D printing. And then 17% use both in-house and a service bureau, and 14% do it with a service bureau. Kevin, again, I'm going to go to you for impressions. Quick impression on that. How did that line up with what you thought we would hear from the group here?
I'm actually surprised 33% don't do any, right? And actually, to be fair, that the combination is only 17%. So it actually, those two are a little more interesting than I would have thought. Maybe we're casting a wider net on who's joining us. You got to get Kevin, that 33% on board.
When do you think then specifically, Kevin, that it makes sense to bring the work in-house versus utilizing a service bureau? What's that dividing line for you when you're talking to folks?
Man, it's really, that's such an individual question. It's hard, and it comes down to economics and timing, right? So there's two things. Sometimes you need the part quicker, right? So you want it in-house, you want the flexibility of it, and sometimes it's economically feasible to have it in-house. Other times it's economically, if you need different technologies, leverage, as we talk about the different processes, obviously much harder to bring those processes in. So a lot of times that makes more sense. And building a case of use, a lot of times outsourcing is better. I would say this, Vince and Dennis have been around a long time, but if you look at service bureaus, it really is amazing. If you take injection molders and all the different services they do, our service bureaus are continuing to expand around additive. So they really offer capabilities that you can never do in-house. And so I know I went around and around on that, but it's an individual case of whether it be in-house or out-house, but both are pretty viable. That's why I was surprised. I figured both would have been a higher percentage.
Interesting. Vince, I know this is a difficult question to tease apart in 30 seconds, but let's give the audience one primary insight from your vantage point as to when it's best to bring in-house versus utilize a service bureau. Vince, how would you reply to that?
I think Kevin brought up a lot of great points. I think one of the big opportunities that in-house has is it brings exposure of the technology to your team and gets your team exposed to it in a way that parts coming in the door won't offer. If it's there, it's at the forefront of mind. It allows maybe access to other departments that could leverage it that wouldn't otherwise have that opportunity, from the quality control folks making fixtures to the engineers to the manufacturing floor to maybe some folks doing assembly work. And so I think having that at the forefront of mind is a big opportunity for having it in-house. Otherwise, like Kevin said, it's a very personal operation specific question. And honestly, I'm surprised more folks aren't doing both in-house and service bureau. We find that quite a bit.
Stella, I see you saying the poll doesn't consider production parts versus service parts. So that's a fair point. Vince, let me come back to you real quick here, and then I want to get to real-time Q&A, folks. Don't leave yet. I want to get to all your questions. Vince, Elizabeth asked this question when she came in and registered for the event today. She said, besides the printer or the printers themselves, what else that we haven't talked about here is needed to implement an additive manufacturing solution in-house? Vince?
Oh, gosh. Besides the printers themselves, I think an open mindset. I think a pragmatic view and an open mindset and some risk tolerance, right? Some patience.
Yes.
It's a new technology. This whole field is still relatively new compared to other manufacturing processes. a little bit of latitude in your expectations, an open mindset to look at value across multiple areas within your organization, and maybe somebody that's very pragmatic to help guide you, because it's easy to get wrapped up in the hype and the coolness of additive. We see that a lot. People are like, oh, additive, let's do it because it's cool. But to be sustainable, it has to make economic sense. And that's where it really needs to lie.
Dennis, I know you mentioned vapor smoothing. So just briefly, in a nutshell, what else are you using to implement additive in your organization besides the printers?
As far as I fall into the category, I do in-house and I still use service bureaus. I can't do absolutely everything with my printer, but there's, like you were saying, there's so many materials and technologies out there. You just got to find what's best for what your needs. But yeah, that is, I need, for my business, I need in-house, I need quick turnaround. And it's a big, everybody else in my field understand what I'm saying. When there's a rush or a repair, it has to happen pretty quickly. So that was very important for me.
Yep. Makes sense. All right. Now I want to get to everybody's real-time questions. I see we have officially 5 minutes left on the clock. So what I'm going to do is I'm actually going to ask the panel here to go into a little bit of overtime. Sometimes we do this when there's a lot of questions, and I can see that there's still quite a bit of unopened or unanswered questions here in the chat. So we're going to hang back, folks, and get to as many of those as we can. If for some reason you have to drop off right now, please drop your best email in the chat, and I'll make sure that the team follows up with you and gets you the recording of the overtime bonus Q&A that we're going into here. So if you've submitted a question so far, we haven't answered it on the air, or my team hasn't chatted with you, please copy and paste that back into the chat right now, and we're going to try to get to all of them. But before I do that, I don't want to forget here, if you want to learn more from Kevin and his team, or for that matter, any of the panelists that are here today, I'm going to ask my team to drop this URL into the chat, 3d.mastergraphics.com. Team, if you can throw that here into Zoom and LinkedIn. And when you go to that link, you're going to see something that looks like this on the screen. Small form you can fill out, takes only a moment, and that'll connect you with Kevin and his team, where they can speak to you one-on-one about where you are in your journey, the unique challenges that your organization and that you are facing, and if they can help, they're ready to assist. So take a moment, you can turn us down and go in and fill that form. My team has dropped the URL into the chat, or will be shortly. My team, please drop that in. There we go. Thank you, Allegra. And when you go there, fill out that form, take a moment to fill that in, and that'll connect us directly with Kevin and his team to talk about how we can help you specifically. So let's get to the questions. There was one that came in that I wanted to make sure, I called him Kevin, but it was actually Ed. What I want to do, panel, is wave your hand at me if you want to take. This is from Ed. And Ed says, we've been able to use additive for manufacturing tools and for prototype development, but I would like to understand how to make production parts cost effective. Additive is well suited for low quantity, but with the cost of equipment, it's hard to support spending. Metal printing, SLS, would work great to eliminate welded structures, but with overhead costs, the parts would be more expensive with poor payback. How can you clarify how to justify? Kevin, I'm just going to put you on the spot here. Let's go with you, Kevin, and then I see Vince. I see you raising your hand. Kevin, thoughts on that?
Vince is going to clean up my answer when I do it wrong. Really, you threw in two things there, right? If you take plastic or polymer type, that's different than metal. To me, metal is still at the infancy. It is still, there's still a lot of post-processing. That's a harder one to go to production unless it's something specific, knee replacements, that type of thing. But on the plastic side of things, look, it is a matter of looking at that, the evolution of technology, and really understanding the overall cost, right? It is engaging someone like Vince that's been in the industry, or hopefully us, or to really look at that part, because that, if you haven't looked at it in the last 2 years, the ability to print in scale is changed dramatically. Vince maybe can build on this. So you just got to continue to assess it, because things are changing monthly and yearly. And so that's when you, even if you looked at it 2 years ago, it might be different today. And again, it may not be a fit but we are definitely seeing production volumes go up. When you look at the start of the service bureaus that are doing production printing of additive, you can just follow the web and see them joining. So Vince, you can clean up my bad answer.
There's really not much cleanup to do. It's a great answer, Kevin. And I think that's an important thing to understand is that, look, it just may not be a good fit for additive, right? You need some level of complexity. If it's easy to do it with injection molding and you're currently doing with injection molding, and we don't have our tooling and we need parts tomorrow, it may continue to be a good fit for injection molding. I ask people to look back in history and think when everything was going to plastics, right? When plastics became in vogue, metal stamping didn't go away, right? Some things are better stampings than they will ever be plastic, just like some things are better injection molding than they will ever be additive. But to echo what Kevin said, there's new tools coming out, new materials, better post-processing, better softwares to create a more compelling design up front that make it make sense. But no, we will never be doing 20-ounce soda bottles cap screws in additive. It just doesn't make sense. It's not the right fit. So
Craig is asking here, and again, wave your hand at me, panel, if you want to take. He's got a two-part question or two questions here. Craig, I'm gonna try to get into both of these here. Craig is saying, number one, is it better to start small, or could there be a reason to go big, like relativity space 3D printed rockets? So is it better to start small, or is there a reason to go big? Who would like to take that one? Yes, go ahead.
I think it's better to start with a problem. So it doesn't really matter big or small. If there's a very complex problem that's not being dealt well with the tools that exist, see what benefits additive can play a role in. And that's why it's been significant in the rocket industry and in the medical industry. I'll let Dennis weigh in on that. I think he's had a huge impact.
Dennis, you want to weigh in on that?
I'm going to say start small, just because I think you just need to get a feel. You need to get a good feel, a good sense of what the technology can do for you and your business. And then I'm pretty sure at some point you're going to want to ramp it up and go bigger. But for me, it was definitely start small.
All right. So second question from Craig: would hardware like bolts, nuts, and washers be a viable option for additive?
Vince, you can answer this one.
Yeah, and I think I responded in the chat there. You know what? Like if you need a 3/8 bolt, no, go to Home Depot, go to Rock, go to Fastenal. You're never going to need it. Now, where it does have an impact is I've seen some fantastically complex fasteners for the medical industry, spinal implants, things like that, where that adds a significant amount of value. Again, it's the value to volume ratio that additive really excels at. And if it's a washer, nut, bolt, not really. No, not unless you're on the space station and you can't get to a Fastenal. Then maybe it makes sense. So you need some pretty extenuating circumstances.
Ed, in response to the commentary a moment ago here, folks said, I would really like to use metal. There's great potential at our company, but I need to justify. Kevin, I don't know if you have any specific questions for Ed around where the justification process perhaps is not where it needs to be, but I'd like to give you a moment, Kevin, to respond to that and ask any further clarifying questions of Ed.
Yeah, I'd be curious, and I don't know, Dennis, your experience with metal, but metal is still, like I said, at the infancy, and it is very hard because a lot of times you got to touch up the part anyways with the machining process. And to me, metal, outside of those home run applications that are being done or replacing MIM or whatever, but a lot of times it's augmenting traditional manufacturing, not replacing it, because you probably got to put it on a CNC machine. So all you want to do is you have a cut path that you can't do, or you want a net near shape. I think we're going to get there, but I still think we're at the infancy of that. And Vince talks about it. We talk about hype of the industry. I think metal got hyped for a long time, and there were some technologies that weren't great, but there's some really good ones coming out. And I just think it's going to take a time for that finishing and the end process to be developed. Vince probably much more, or maybe Dennis, I don't know Dennis's experience with metal, but I would have them add to that.
Bella,
Yeah,
what would you say?
I completely agree with Kevin. I think that some of these binder jet processes are going to create a new window of opportunity, probably in that 50 to 5,000 part range. There's tools, there's ways additive can play a role. Additive has had a huge impact on the sand casting industry for low volume production or very complex core sets. It's had a huge impact on quick turn investment casting. So it's played a huge role, but it's a common question we hear from our consortium members and from other folks when they have a commodity part and they go, does this make sense to do in additive? On a laser-based metal system, you're still looking at a couple $100 per cubic inch in cost. And so if it's a little bracket that you can easily machine, then no. But if it's a complex component, whether it be a little finger or fixture, so think of highly complex little nuggets or organic structures. Again, that's why you've seen so much impact in the medical, dental, aerospace areas, because there's a lot of complexity to that cubic inch volume, and you can pull that value out, right? Titanium, Inconel, these materials that are not easily able to just go get a big billet chunk of it and start carving it off. That's where it makes sense.
David Holman, I see your hand up here in the chat. If you've got a specific question, David, please throw it into the chat there. I'll make sure to get that. If you're here in Zoom or if you're here in LinkedIn and you're getting value from the panel today, I want to make sure you give them some X's and O's here in the chat. Give us some X's and O's. Open up the chat wherever you are right now. Drop some X's and O's in there if you're getting value from these folks and the answers that they're giving to your questions. I want to make sure I get to a few more of them. David, that's okay. No worries. I thought maybe you had a question there, but let us know if you're getting some value. Give the fellows here some love. And I'm going to hit a few more questions here. I know I'm holding you all past the hour mark. I appreciate all of you here in the audience sticking around, as well as the panel. Kevin, I'm going to throw this one at you, rapid fire here. What are some of the different types of materials that can be used in 3D printing? Give us a list of just some of the, what are some of the materials we're seeing?
It has expanded so much. I would say literally now there's thousands, right? So you're, and again, take that polymers and metals, but there's everything from nylons to TPUs to polypropylenes to, it's almost too much. If you know the material, it's probably 3D printed. The challenge is, what is the process to 3D print that? And will it mimic what you're thinking of from a traditional perspective? But materials is almost impossible to keep up with, but it's wide ranging. I know, I love the non-answer when everyone's asked, but that's where, unfortunately, materials is another one is hard to keep up with as technology. Yeah. And usually the challenge is, don't read that it's a TPU or a peak or whatever. Read how it's being done, because that affects how the part or the material will act.
Let me hit Samuel's question here. I just threw it in. Thank you, Samuel. How to navigate hobby versus consumer versus high-end printers? Is it more cost-effective to go with small printers versus large, high-end printers? I know that's probably a multifaceted question there. Who would like to address that?
I can weigh in a little bit, and then I'll let Kevin take over. I'm sure he'll have a different or maybe a similar viewpoint. Those lines are getting blurred, but so much of it comes down to your applications. I've seen folks do some great stuff on low-cost Perusas, some $300 extrusion printers. And I think some of these lower end printers, I shouldn't say lower end, lower cost printers are doing exceptional work. I look at the progress and improvement that a company like Formlabs has made, exceptional. That being said, you look at, there's just certain applications and certain projects that you cannot do without a large format industrial printer. HP, MJF, Carbon, 3D Systems, EOS, they've released game-changing hardware, and I think that it comes down a lot to your application. So they're all getting better, put it that way.
Anybody want to add on to that?
So I add, and then I'm going to throw it to you, Dennis, because I know Vince and but I would say The thing it is actually amazing. Vince is right. What Form Labs have done, Perusa, these entry-level printers are pretty exceptional in what they do. The only thing I ever caution is don't buy a lower cost printer expecting to fix a bigger problem, because that to me sets customers back and clients. If you're going to invest to fix the solution, don't try to fix it. And we see that too often. Vince talked about it earlier, where people get turned off the technology. They buy a entry level or low cost system trying to fix a high cost issue, and it doesn't work, and they go, additive doesn't work. That's probably another bigger challenge that we have.
Interesting.
Yeah, I don't want to jump the route here, but Kevin, that's a great point. It's so many companies have come to us that have had a bad experience with additive, and their bad experience with additive starts because they didn't try to fix the solution. They had a budget for a 3D printer and they went out and bought one within that budget instead of finding a use case, finding a challenge that they needed to address and attacking it that way. So don't let your budget have your printer choice. Let your application drive your printer choice.
I'm going to hit two questions here, one from Chi and then from Scott. I see both of those. Chi, hopefully I pronounced your name correctly. Forgive me if I did not. But the question, and panel, raise your hand if you can answer this. How about radiation hard materials? Can PLA be a reasonably good choice? Who can handle that? Oh, Dennis, looks like it's going to be you.
Yeah. No, actually, that's not my wheelhouse, David. I'm more of I would have to say there's an application. You'd have to check with some engineers that are involved in that area of medicine. But maybe
all right.
Vince?
Kevin? Vince?
That's above my pay grade.
Okay. All right. Good job, Chi. All right. Let me hit the next one from Scott then. How much are you willing to invest in calibrating or adjusting the printer? Some people are serious experts in running low-dollar printers and can get great results, but if they leave, nobody knows how to work things. How do you answer that?
That's a great point. I don't know as much as a question as it is a great narrative and great comment. And I know Scott, he's exceptional. He's a very talented engineer, and he's 100%. And a lot of times it will go back to that dovetails well within what you get from a value standpoint with the different levels of printers, right? If you're a tinkerer, if you can keep these printers running, you can get exceptional results from low-cost printers. But are they going to be as robust and reliable as the larger industrial ones? Probably not. So it's a trade-off, right? I think that's a great point that Scott made. I'll take it as a point more than a question at this point.
There we go. All right, folks. I know I've held you a lengthy duration past our official end time. I appreciate the panel, but I want to ask everybody here in the audience one more question. If you can open up the chat right now, LinkedIn and Zoom, and take a moment to think about this question. What's one thing that stood out to you today? What was like an aha moment or a light bulb moment or an insight that one of the panel said or maybe illustrated or articulated in an anecdote that stood out to you today? I want to give you a few seconds to think about that and then drop that into the chat, please. What's something that stood out today? I still see a lot of you here in Zoom. I'm going to try not to talk too much so I don't distract you. But we always like knowing what stands out to you. Very helpful to us to help you. And then I'm going to read off the responses. Thank you, Stuart. I see yours here. Barb, let's get yours. Brent, Chance, Charles, David, Dean, Douglas, Ed, Elsa, Jacob. All right, I'm going to read off a few of these here. So we've got from Stuart, using the problem to justify the solution, not the cost. Yep. That one stood out to me as well. Jeff says value to volume ratio. Anusha, forgive me if I got if I mispronounced your name, but ideas about conversion to a large-scale production of additive manufacturing. Ed says stronger encouragement to get hobby printers to acquaint. Hopefully I got that right. Barb says don't let the budget drive printer choice, but the application or the need. Lawrence says the use of CAD for design. James says the standout for him was metal 3D printing is in its infancy. Ray is saying that it eliminates long lead time of tooling. Interesting. Yeah, These are very helpful, folks. Please keep these coming in. Kevin, I want to give you the opportunity to say a few closing words here, and also remind everybody, if you want the recording of today's event, if you want to get any additional information from Kevin, I'm going to have my team drop the URL. Team, please drop that into chat and into Zoom here, LinkedIn and Zoom, and take a moment after this event to go in and fill that form if you want to talk further to Kevin, or for that matter, any of the experts here about how to take the next step in your journey. Thank you, Allegra, for dropping that in. Kevin, I want to give you an opportunity to say a closing word here.
No, again, I want to thank the guests, right, Vince and Dennis, for joining and you hosting, just because, again, I love, these are informative, right? I love they're not product-based. I don't know if you saw, Vince, someone actually said you're the smartest person in the room. Dennis and I
did see that.
were offended by that. But
That's
yes,
the best $10 I ever spent.
I know. I think it was your son. But anyways, I know. So I appreciate it. Like I said, you guys taking the time out. We just, again, I'm passionate about the industry, that we keep moving it forward, and appreciate these two brilliant people join us. So thank you for that.
Thank you, fellas. I appreciate everybody. Thank you to you, Kevin, to you, Vince, to Dennis, but most importantly, to all of you who are here in the room with us. Thank you for spending time with us today. I hope you got value out of it. Thank you all for your time. Have a wonderful rest of the day.